Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Irfan Iqbar from Management. In this video, I want to give you the explanation of a system of nonlinear equations. A system of nonlinear equation is a system of two or more equations in two or more variables containing at least one equation that is not linear. To solve a nonlinear equation is determining the roots of the nonlinear equations. In other words, the root of the equation f of x is the intercept between the f of x curves and the x-axis. Let's move to the quadratic function. The quadratic function is the equation for the variable that has the highest positions, while the general form of the quadratic function is f of x equals ax squared plus bx plus c, where a and b are coefficients and c is constants, as well a is not equal 0. The quadratic function can be called y equals ax squared plus bx plus c. The graph can be made by entering the x value at certain intervals to get a value to the coordinate from which a graph passes. For example, the graph of the f of x equals x squared minus 2x minus 3 function is: first, you must make a table of a coordinate like this, and a graphing like this. And here the example. Now we're moving to the exponential function. The exponential function have the form f of x equals b to the exponent x, where b is greater than 0 and b is not equals to 1. An example of an exponential function is the growth of the bacteria. And if you start with one bacterium and it doubles every hour, you will have 2 to the exponent x bacteria after x hours. This can be written as f of x equals 2 to the exponent x. And this is how to count. Before you start, f of 0 equals 2 is power 0 equals 1. And after 1 hour, f of 1 equals 2 is power 1 equals 2. And so on. With the definition f of x equals b to the exponent x, and the restriction that b is greater than 0 and b is not equals 1, the domain of an exponential function is the set of all the real numbers. The range is the set of all the positive real numbers. The example is: next, we move to the logarithms. The logarithm of a number is the exponent to which the base must be raised to produce that number. Example: how many 3's do we multiply to get 81? The answer is 3 times 3 times 3 times 3 equals 3 to the power 4 equals 81. So the logarithm to the base 3 of the 81 is 4. For another example, what is log base 5 of 625? In this case, we were asking how many 5's need to get multiplied to get 625. So we need 4 lots of 5's. Therefore, the answer is log base 5 of 625 equals 4. So here's a logarithm rules. Now to graphing logarithm function. The function y equals log base b of x is the inverse function of the exponential function of y equals b to the exponent x. Consider the function y equals 3 to the exponent x. It can be graphed as: the graph of inverse function of any function is the reflection of the graph of the function about the line y equals x. The graph of the logarithm function y equals log base b of x, which is the inverse of the function y equals 3 to the exponent x, is the reflection of the above graph about the line y equals x, like this. And now is a natural logarithm. When a to the power y equals x, then base e logarithm of x is ln of x equals log base e of x equals y. And here's a natural logarithm rules and properties. The example of a natural logarithms. And that's all. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.